Depth education. Let us continue with detection of anions, and we look at our last anion here. That is the fourth anion, and it is the nitrate. Ion. NO3 minus. So let us also have our table as we have been doing. Let us have our table. So in our table we shall have test, observation, and then the deduction. Test, observation, and then deduction. So let us look at the first test that we can use for detecting nitrate ion in a solution. Add freshly prepared ion to sulfate solution followed by concentrated sulfuric acid carefully down the side of the test tube. So in this case, this test is for detecting nitrate ion in a solution. So this one is for a nitrate solution. The nitrate solution is a solution containing the nitrate ion. So to that solution, and remember that always we use just 1 cubic centimeter of the solution under test. So we have to firstly add freshly prepared iron 2 sulfate solution. Take note here, we are saying it should be freshly prepared. Freshly prepared means that you prepare the solution and use it immediately. Don't let it first rest because of what, or don't let it first stand because of what we saw yesterday, that a solution containing iron 2 ion, in this case iron 2 ion, is not stable. It is easily oxidized by atmospheric oxygen from iron 2 to iron 3 by the loss of an electron. Just as simple as this. Iron 2 ion, let me use this part here. Iron 2 ion will be converted to iron 3 ion by the loss of an electron. So this one is green and this one is brown. So we must know that if you leave a solution containing iron 2 ion to stand for some time, just you see it changing its color gradually from green to brown because of atmospheric oxidation. That is oxidation by the atmospheric oxygen from iron 2 to iron 3. So we need iron 2 sulfate, not iron 3 sulfate. And for that reason, let that solution be freshly prepared. Prepare and use it. So to the solution which is under test, you add your freshly prepared iron 2 sulfate solution, and then you also add concentrated sulfuric acid carefully down the side of the test tube. Why we do it this way is to avoid spillage, because if it spills on your body, the concentrated acid is extremely corrosive. It will have to hurt you. And also if you pour directly, it will of course react with some of the water which is in that mixture which you have in the test tube, and then there can be some bumping upwards. Do not shake that mixture. So when you add the freshly prepared iron 2 sulfate solution to the solution containing nitrate ion, and then later on if you add the concentrated sulfuric acid carefully down the side of the test tube, then you'll be able to get a brown ring. You'll see a brown ring at the point where the acid meets the mixture. Excuse me. In the test tube. So, a brown ring will form at that point where the acid meets the mixture in the test tube. And we say, do not shake this mixture. And this one here signifies the presence of nitrate ion in that very solution. So, this test, sometimes we call it the brown ring test. The brown ring test. So, the brown ring test involves the use of the freshly prepared iron 2 sulfate solution and then concentrated sulfuric acid. The addition is in this very order and in this very manner here. So don't forget this, and remember that sometimes they ask you to carry out a test of your own choice to confirm the presence of the nitrate ion in a solution. So you must not forget this brown ring test, and then don't forget that you are not supposed to shake this mixture. Don't shake it. Let me put it somewhere here in red. For this test, do not shake. It's not required. Don't shake in any way, because you just have to let the reaction take place on its own, and you'll be able to see your brown ring forming. So this one is for a nitrate solution. You may also be having a solid nitrate. So if it is a solid nitrate, remember this one is for ordinary level. We are not going to go to other tests. So in this case, if you have a solid nitrate, you are supposed to heat a spatula and full of a solid strongly until no further change. We know very well that our tests here, we carry them from a test tube. So if you are heating a nitrate, the first thing you'll be able to observe is a crackling sound or a decrepitating sound. So we shall get a crackling sound. The crackling sound in this case signifies decomposition or breakdown by heat. That is thermal decomposition of the nitrate. So you'll be hearing that crackling sound. Some minor explosions as the nitrate decomposes to produce nitrogen dioxide gas, which will be observed as a red-brown gas. If you are using red-brown, please put this hyphen here. And if you are saying reddish-brown, then there will be no hyphen. Reddish-brown, then you will have no hyphen in the middle here. But if it is red-brown, put that hyphen in the middle. And I'm using red-brown in this case. A red-brown gas with an irritating smell and which turns moist blue litmus paper to red. So it is an acidic gas. The gas which we have seen, which has got this characteristic red-brown color, and then it has got an irritating smell, and it turns moist blue litmus paper to red, is nitrogen dioxide gas. So it is nitrogen dioxide gas which has been produced, and therefore we have got the nitrate ion. So you now have to sharpen your knowledge on the writing of the equation for the decomposition of a nitrate. You know how nitrates decompose, or the action of heat on nitrates depending on where that particular metal belongs in the reactivity series. So most of our nitrates, apart from ammonium nitrate, they produce their respective oxides, nitrogen dioxide and then carbon dioxide gas. So you pick any one of them, and this one here, the equation will help you so much in paper 2. I want to pick a simple example which is not supposed to be here. Let me use, say, zinc nitrate. If I heat zinc nitrate, basing on the position of zinc in the reactivity series, it is a moderately reactive metal, not highly reactive, not even almost unreactive. It is in the middle of the metal reactivity series. So it produces zinc oxide, it produces nitrogen dioxide, and it produces oxygen gas. So these are the products of the reactions, of the decomposition rather, of zinc nitrate. It is the same thing with the calcium nitrate, magnesium nitrate, and all those other nitrates apart from ammonium nitrate. So they produce their oxides, nitrogen dioxide and oxygen. And then we balance the equation. One zinc atom, two nitrogen atoms here, we have 1 multiplied by 2, and then oxygen atoms here are 6. These are 4 plus 1 is 5, and then we have 2 here. We multiply oxygen by a half to get 1 oxygen atom. Then we multiply all these chemical species here by the denominator here, which is 2. So multiply this one by 2 becomes 2, this one by 2 becomes 2, this one we multiply by 2, it becomes 4. We multiply a half by 2, it becomes 1. And this one is a balanced equation with only whole numbers for this reaction here. So this is just but an example, but it is not part of our qualitative analysis. It will help you so much in paper 2 and even in paper 1. So this is the account of the detection of the ions in, the anions in qualitative analysis. So this is how we get to detect nitrate ion in a solid, and this one is for a solid nitrate. And this one is for a solution of the nitrate using the brown ring test. So please, this is the account of what we call ionic chemistry and qualitative analysis. We are going to have a look at some questions that we shall have to relax with that can help us, in this case, in our paper 2. So in our next session, we shall have a look at that. Tech Talks Education, thank you for watching.